3.4 Volume and capacity of spheres, cones, and pyramids. So in this video we're looking at volume again, and this time it's talking about spheres, cones, and pyramids. So, new skills. Working with volume and capacity of spheres. The volume of a sphere is calculated using the following formula. So notice the volume of a sphere. It's a little bit similar to the area. If you remember rightly, area of a sphere was 4 pi r squared. This is a little bit different. We're dividing the 4 by the 3, but we're also multiplying by another r. So this is the area of, this is the volume of a sphere. The capacity of a spherical container can be calculated the same way it was for a prism. So if our prism or sphere is empty, the capacity is the same as the volume. So start by calculating the volume, then we can convert to the unit of capacity, which remember was 1 liter or liters. So when we calculate the volume in centimeters cubed, we can then convert to liters by dividing by 1000. You'll also need to know how to convert between cubic meters and cubic centimeters. So how do we go from meters to centimeters? Well, we know that because there's 100 centimeters in a meter. So if we have so let me just tell you that we're not talking about meters and centimeters in this, but let's just look at meters. How do we go from meters to centimeters? Let's just say we have, 6 meters. How do we go to centimeters? Well, as we go to a smaller unit, we typically get larger in number. And there's 100 centimeters in a meter. So therefore you know that it has to be 600 centimeters for 6 meters. So in going one way, we're multiplying by 100, and the other way we're going, so in this way we are multiplying, and this way we're dividing by 100. One way to think is as you go to a smaller unit, you go to a larger number, so you know whether to multiply or divide. However, we are looking at, in volume, we're looking at cubic meters. We're looking at meters cubed. And how does that relate to centimeters cubed? Well, it's a little bit different. If you think of this block, it's a meter by a meter by a meter. That means up here we have a little cube in the corner here that's 1 centimeter by 1 centimeter by 1 centimeter. And there is 100 of them along here, there's 100 of them along here, and there's 100 of them down here. So let's just say 100, 100, and along here 100. 100 little centimeters, 100 centimeters, 100 centimeters in a meter. So when you end up calculating this in centimeters cubed, this is really a million. 1, 2, 3, 1, 2, 3. Centimeters cubed. There'll be 1 million little cubic centimeters in this meter by meter by meter in this 1 cubic meter. So 1 cubic meter is actually 10 to the 6. 6 zeros. 6 zeros. 10 to the 6 cubic centimeters. So we multiply, going to the smaller unit again, we multiply, and going to the larger unit we divide, but this time it's by a million to go from one unit to the other. So that's what they're showing right here. So just keep that in mind when you're converting. So therefore 1 cubic meter is equal to 1 million cubic centimeters. So what's the capacity? You would have to divide this by 1000 to change it into liters. So that would give us 1000 liters. Example 1. Spherical exercise ball has a diameter of 1.2 meters. What's its volume? So, little diagram. What's its volume? If you remember, the volume of a sphere is 4 over 3 pi r cubed. And we plug in the radius, not the diameter, so be careful, this is not the radius. So we'll have to divide this by 2 and get 0.6 for the radius. And then we can plug it in right here for the radius. Do this first. Remember, bed mass, we cube 0.6, then multiply by the pi, then multiply by 4, and really everything then gets divided by 3. Another way to write this is 4 pi r cubed, all divided by 3. Okay, so they take you through this calculation right here. When they get the answer, remember it's in meters cubed, so they're going to have to multiply this by 1,000,000, which they do here. Here's the calculation, to get the cubic centimeters. And then divide by 1,000 to get to liters, which they do down here. Capacity ends up being 905 liters. And some exercises there for you to try. Okay, some new skills, working with volume and capacity of pyramids. So, a little bit trickier. It's a volume, but we do have a formula. Again, like a cone, you'll see in a minute, to get the volume of a thing like this, it's not a rectangular prism. If it was a rectangular prism, it would be base times height times width. But for a pyramid, it's actually a third of the length times width times height. Sorry, I think I said base. So yeah, length times width times height would be the area of a regular prism, but we divide it by a third if we want a pyramid. So using that formula, they'll calculate the volume of the capacity of this pyramid right here. They need the length, the width, and the height. So one thing to remember about the height, it's the vertical height, tip to the middle of the base. So what do they tell us? They give us the diagram only. This is 18 by 15. The height here is 25. So we can simply fill in the formula. 1/3 of 15 times 25 times the height of 18 gives us the volume. That's the volume in cubic centimeters. So they want a capacity, they have to divide again by 1,000. So giving us a value of 2.25 liters for the capacity. Just scrolling down here to see what else is going on. Okay, I'll do one more example here. Example 3 is calculate the volume of this pyramid. Remember, if we're calculating the volume, we need to go 1/3 the length times width of the base times the height of the pyramid. Trouble is, although we have the length and the width of the base, we do not have the height. So we're going to have to calculate that. They tell us this little length here is 22. Why did they tell us that? It's because it's going to be helpful in calculating the height. I'm going to mark this as H. This is a right triangle, and this length here is half the total length across from side to side, so it's half of 26. So this here is really 13 units right here. So we have a height and the base of this triangle. Height we need to calculate. This is 13. They tell us this is 22. What's the calculation? Well, remember, for a right angle triangle, this side is the C side, the hypotenuse. So we have A squared plus B squared equals C squared. So height squared plus 13 squared equals the hypotenuse squared, which is 22. So height squared will equal 22 squared, I'm going to bring the 13 squared to the other side. So I have to subtract it off both sides. And now you get an answer for height squared, which you've got to square root. So let's look at how they do it below. So here they've written it here. They brought the 13 squared to the other side. They work this all out in their calculator, no doubt. 22 squared is 484. 13 squared is 169, giving 315 when they subtract. Now they have to do the actual square root to get 17.7. Okay, so that tells us the height. And they've left it as b, but now the height is 17.7. They can plug it in along with the base of 26 times 18 and get the volume. Capacity is going to be this divided by 1000, remember. And some other examples to finish off. And I'll leave the next part to the next video. Okay.